and hope you can see us all over there. Can you see us? Yeah, there we go. You're seeing my living room, I guess. Here we go. We are scrambling today because okay, where am I hearing this? We're scrambling because the link to get into the room, I was sending out the wrong link for that. I was sending out the same link I always send out from the same position, as far as I know, but it was apparently the wrong link. Any rate, what we really came for was to hear from Ron Brecher, and Ron, his little face is down here on the screen for us, and so everything should be okay. And he will be telling us about some advanced math in PixInsight and how to use it to process your pictures better. Remember that next week that a number of us will be out in New York, so that we won't be able to see you, and we won't be able to put on a show for you. We'll be working on other shows for you. I've got some bad news. Ray had to cancel his April 12th, which is the week after that, for telling us about PemPro, but we're working on getting an alternative for that. And then we've got a whole lineup of other people. But rather than take any more of your time, I'd like to introduce Ron Brecher, and Ron's going to take over, and he's going to tell us about, Ron, take over and tell us about what you're going to tell us about.
All right. You should be able to see my screen. Can you?
Yep.
You're good. Yes, we can.
Okay. So I'm just going to talk a little bit about the power of pixel math. Pixel math is just what it sounds like. It's a tool for doing mathematical operations on your images. This is going to be a very short presentation followed by some demonstration. So just to give you a quick overview of pixel math and what it can be used for. Although I have demonstrations listed third, I'll go through the resources and then we'll switch over to a live demonstration with PixInsight. Everybody still with me?
Yes, we are.
Great. So this is what the pixel math process window looks like. And I want you to notice it has two main areas. One is the expressions area up here. And sorry about that. The other one is the destination in the bottom half. Expression is where all the math happens. Destination is what you want to do with the result of that mathematics. So you can either replace the target image or make a new target image. This little button here, the expression editor, when you click it, it gives you access to a place where you can type mathematical expressions using images, symbols, and you have access to all kinds of functions, operators, punctuators like brackets, and defining symbols. So I'm going to show you all of those things. This is, I did say this was going to be sort of advanced pixel math, but we'll start with a couple of easy examples, and then I'll show you some really cool things that it can do. So the main uses of pixel math are for creating masks, blending images, and doing selective editing. And for creating masks, I'm going to show you how you can start with a few simple masks and use things like subtraction of one from another or the maximum operator to make a mask that targets just the thing that you want. When I talk about masks, I think of them like stencils. You know, if you wanted to paint a word on a wall, you'd use a stencil where part of the wall gets protected and the paint just goes through where you want the lettering. So I'm always thinking, how can I make a mask that selectively targets just what I want? In terms of blending images other than masks, I'm going to show you how to blend before and after images. When you've applied something and maybe it's just a little too salty for your taste, you can blend it back into how it was before that application and use pixel math to control the way that's done. I'm also going to show you a really dramatic addition of H alpha to LRGB using nothing but pixel math. And we might actually start out with that so you see where we're going with this image. And finally, if you're like me, your backgrounds aren't perfect. And if you look really close, there's often some dark modeling in the background of deep sky images. I have a nice little pixel math expression that reduces that dark modeling, and I'm going to demonstrate that for you. There's a bunch of resources that have more information on this. I was the technical editor for the first and second editions of PixInsight, and a lot of the pixel math stuff that I'm going to cover tonight is covered in the book and also in the ip4ap.com tutorials. There's a bunch of good free tutorials, and I've listed a few here. The PixInsight forum, most of us got our start with Harry Page, Harry's AstroShed, lightvortexastronomy.com, and PixInsightResources.ar. Those are all free tutorials. Do beware of misinformation about PixInsight online. There's a lot of it out there. Okay, with that, I think I'm going to switch over to PixInsight and ask if everybody can still see me and hear me.
Yeah, we're good, Ron.
Okay, good. So I have 4 masks here. If anybody wants me to go through how these masks were made, I can do that, but I was just planning on telling you that the source image for the top 2 masks is this RGB image. So you can see there's a large, dim nebula, slightly brighter nebula. This is a non-linear image, so this has already been fully processed. This is what I was able to get out of that. The bottom 2 masks come from the H alpha of the same image. I'll just get rid of these previews right now. And you can see there's a really good H alpha signal. There's a lot of signal right down here at the lower left, which is going to create a challenge when I do this blending. This could really overwhelm the image. So just keep that in mind. So the bottom 2 masks were made from this H alpha. The top 2 masks were made from the RGB. And so I just want to show you a couple of ways that you might be able to combine these masks using pixel math. So let's start with opening up pixel math, which is in its own submenu here. If you can't find stuff in PixInsight, you can always find it in the alphabetical list. There it is. And I'm just going to reset the tool with this little icon at the lower right. Most processes have that. And you'll see here's where I get to put in my expression. Now, what if I want to boost the saturation, color saturation in the nebula down the road, but I want to protect the stars? Well, what I can do is I can open up my expression editor and select my range mask. I just double click to select this image and subtract from it my star mask. Once I've put in any expression here, I can parse it to see if it throws an error. In this case, everything looks good. No colors, warnings, nothing telling me that I need to fix something. So I can close the expression editor, and you see the expression that I wrote here is populating the RGB line. Now, if you're working on a color image, you can unclick this box here, and that will allow you to write separate expressions for the R, G, and B channels. But in this case, we're working on masks. They're monochrome images. So we're just going to go ahead. We want to subtract the star mask from the range mask. That takes care of the expression. Now let's focus on the destination. I could replace this image, but I think I'd rather create a new image. And we'll let it be automatically identified. And now I can just click apply. And there's my new image. So that's the first demonstration of how we might use pixel math to protect the background and the stars and single out just the nebula for some type of treatment. Any questions about this? First of all, I have a question. Can everybody hear me?
Yeah, you're doing fine,
Okay,
Ron.
good.
We can hear you
Okay.
good. We can hear you well.
Okay.
And we do have 35, I think it said over there, 19. Yeah, we got 35 people over there watching online and asking questions. Yeah, if any of them are relating to something you're talking about, we'll interrupt you, or we'll wait for you to pause, and then we'll throw you the question. Otherwise, we'll let you go on with your presentation. Stopping every now and then to make sure everything's hooked up. Okay.
Yeah, that's great.
Thank you. Okay, bye-bye.
Now we can do more work on this mask that we just created. So for example, maybe I told you that this is going to kind of dominate things if I'm not careful down the road. Maybe I want to subtract that out. And I have a mask here that I could subtract from this guy. So let's change the expression here. This is image 15. So I'm going to start with image 15, and I'm going to subtract my HA blend mask. Parse that expression to make sure everything is good. And if it is, this time let's replace the target image. So now you see all of this area is grayed out. And now when I apply it to this image 15, we should see this being subtracted from this. That should just dim this area down a little bit. So let's see what happens here. So you can see how we can be really surgical with pixel math about adding and removing things. Okay, I'm going to go ahead and just save this down at the bottom in case we ever need it again. Sometimes, rather than removing stars, as we just did, we'd like to add the stars. And there's a really neat operator called the maximum operator. Let me just reset the tool and open up the expression editor. So now we get to see, in addition to this images menu, for double-clicking our images, we can select functions. You can read about all of this. This tool is fairly well documented. I'm looking for the max operator. And if I just click on it, this middle window over here tells me how to use it. So what it does is it returns the maximum value of a set of 2 or more arguments. Argument means images. So let's double click that to load it into my expression. And now I have to tell it what to compare. And in this case, I'm going to compare the range mask and the star mask. I can type it in, or I can double click. So I want to compare the range mask, the star mask, and whichever is the brighter of those two is going to become the value of the pixel in the new image. So we're going to parse it again. Everything looks good. Let's create a new image. So again, we're going to compare this image with this image, so bottom left and upper right, and whichever is the brighter, that becomes the pixel value in the new image. So now we have a nice tool to boost the saturation, for example, or adjust the hue of the stars and the nebula without affecting the background. And again, we could subtract this if we wanted to dim this down a little bit. So you can apply multiple iterations of pixel math. All right. Let's
Could we hold for a second, Ron?
yes.
John wants to know how you got the smaller nebula mask. How did you create that?
This one here.
I'm assuming that, yeah.
So
John,
that was created from this image using mask generation range selection. And what I did is adjusted the settings to get the mask that I wanted. Like that.
Thank you. And Alex wants to know, do you have to type in the punctuation? As I noticed there were commas and parenthesis marks and things like that appearing.
Yes, yes, you do. So if I just open up Pixel Math again, it'll have the last settings that I used. Yes, you do. So in this case, the comma is separating the names of the two images.
Now, could you have put, you said you were going to subtract the little nebula. You know, you could have put that in that same line, right?
I could have. So why don't we do that? That's this little guy here. So we'll open up the expression editor and go to the end of the line and subtract the H-alpha blend mask. In fact, let's be really aggressive and subtract 3 times the value of the H-alpha blend mask. You see the flexibility that we have here. Now we're going to just check that everything's good. 3 referenced images, everything looks good.
Would you mess something up so we can see what it looks like when it messes up?
Sure. Let's do this. That's a common mistake that I make. Invalid character in numeric literal.
Thank you.
Here's another one that I often make. Although it's hard with the color. It's matched left parenthesis. Okay, so this parsed, everything looks good. No problems, reported. So let's create a new image. So now it's going to take the brighter of this and that and subtract 3 times the value of that.
Okay. Okay, there it is. Oh, that 3 times really takes it out, doesn't it?
Yeah.
Okay, Steve wants to know, when you use multipliers, do you need to rescale?
It depends. If you're using multipliers on a mask, it depends on what you want the mask to achieve. So rescaling is optional. But if you're doing it on a real image, then you will want to rescale if you're doing multiplication or addition. Usually you don't need to rescale if you're doing subtraction.
Okay.
And division you won't generally use.
Okay. That's all the questions we've got.
So I will point out when rescaling is helpful.
Okay.
But right now, I'm just showing you how useful it is for making masks. And if you find that that multiplier of 3 is too high, you can change it to 2 and try again. still very aggressive. So now we can try one. There we go. More like it.
Okay.
But again, the point here is really to illustrate the maximum function and the fact that you can have multiple parts to your expression. So I'm going to close this right now, and I just want to show you one other cool thing that you can do with pixel math. Sometimes you need to use the clone stamp tool to paint on a mask. I don't paint on images, but sometimes I paint on a mask to make the mask target the thing that I want. And often I'll want a black paint bucket and a white paint bucket. And I want to show you how pixel math can make them. So I'm going to make a clone of this, and I'm going to call it black. And I'm going to call this one, rename it white. Now I'm going to open up pixel math and reset the tool. And I'm going to set every pixel equal to 1. So there's that expression. So every pixel in the target is going to equal 1. So now I'm going to apply that to the white image. There's my white paint bucket. Anybody guess how I'm going to apply it? Make a black paint bucket? I'm going to apply the value 0 to every pixel in this image. And now I have 2 paint buckets that I can work with the clone stamp tool. So I'm going to pause there and see if there's any questions.
No, we're good. Keep going, Ron.
Okay. Well, I think that's enough to show you about masks. I did say that this was going to be a little bit advanced. So let's do some stuff that's a little bit more advanced. And here's our RGB image, and here's our H-alpha image. And I want to show you how those can be combined. So I'm going to shrink that down. You don't need to see it anymore. Here's the expression that we're going to use. In this case, we're using a different expression for each of the color channels. So let's look at them one at a time. $T, this symbol here, $T, that's PixInsight speak for the target image. This is the target image, my RGB image. The target image has 3 channels, channel 0, channel 1, and channel 2. So what I want to do is I want to do a comparison of the RGB and the H-alpha channel by channel. So first of all, let's look at the green channel. This just says whatever it is now, leave it the same. So the value in the new image is going to be the same as in the old image. This one is saying compare the red channel with some multiple, in this case 1.2, of the H-alpha image. And whichever is brighter, make that the value of red in the new image. Then the blue one is got even a slightly tougher thing. It's saying if this thing is true, do that. Otherwise, don't do anything. And so what is this? Well, if the red channel was fainter than the H-alpha, then we need to add a little bit of blue. And the amount of blue I want you to add is 6% of the H-alpha. And the reason for that is that hydrogen alpha doesn't only emit in the red, it also emits in the blue. And if you leave this line out, you get an overly red result. So again, red channel, compare the red and the H alpha, or 1.2 times the H alpha, whichever is brighter, that's the new red. Green stays untouched. Blue, if you changed the red, then add a bit of H alpha to the blue. Otherwise, leave the blue alone. And let's see what happens when we do that. Okay, this would probably be a good place to stop and see if there's any questions.
The questions about your topic, we have another conversation going on over there, which is okay. It happens lots of times. But I'm really enjoying listening to you methodically go through this. So keep at it, dude.
I'm going to press on in that case. Now, suppose I think that this is a little bit too hot. Remember I said that would be a little hard to handle? I'm going to just make a copy of this image and put it over here. I'll shrink it down so it's out of the way. Just move it up there for now. And I'm going to go back a step here. And now I had my little HA blend mask. I'm going to put it on here, but I'm going to invert it. So now when I add this H alpha into the RGB, there's going to be a little protection here. So here we go. All right. So this got some protection. This didn't get any protection. What if I want a blend of both of those? Well, first I'm going to take the mask off. And let's open up Pixel Math and reset the tool. And open the expression editor. This time, instead of numbers, I'm going to go A times RGB plus B times RGB clone. And I'm going to say A equals 1 and B equals 1 to start with. Now let's parse that. Good. There we go. That's what this looks like now. You see now what I'll be able to do is vary A and B until I get a blend that I like. So let's just minimize these two input images, get them out of the way so that we just see what comes out of Pixel Math. Now here, I need to rescale. And let's show you why. Well, I'll do a one-to-one blend first. That will make it obvious why I need to rescale. See how it's blown out? If I click rescale, I get a much more natural blend that is a blend of these two input images. And the reason I need to rescale is that when you add these two images together, some of the pixels would have a value greater than 1, and they would just be clipped. Rescaling rescales everything all back between 0 and 1. But now suppose, remember the RGB clone is the hot one, the one that's too hot. Maybe I want a little bit more of that hot one, so I'm going to change this to a 2. And let's apply it. Now we can, there's a cool feature of PixInsight. We can make a preview here and drag this previews window over here and select it as well. So now we can compare them a little bit. So you see this is a little hotter than this one. I see it particularly over here that I've lost some detail in here. Anyway, you can see that these you can use symbols here so that it makes it really easy to adjust how you're blending two images. Okay, close both of those, and we don't need the clone anymore. Let's close Pixel Math. I want to show you the how to fix those dark pixels. And that is here. So this is just a crop of the image. This is fully processed, so this is almost almost done, almost finished cooking. And it's we're zoomed in 1:1. It's really just the bottom right-hand corner here. It actually looks pretty good, but if you stretch it, just for the purpose of visualizing it, if you stretch it, if you really stretch it, you can see there's some dark pixels there. Let's make this really obvious. Do you see the modeling all around here? Well, it'd be nice if we could get rid of some of that. And remember, of course, we're stretching like crazy, but now that you know it's there, you can never unsee it. All right. Here's my pixel math expression to fix black pixels. And it does it one channel at a time, but in principle, it's the same. So you set a target number of this variable A, and that is the brightest pixel that you would consider needs correction. So if I hover around here, I can see these values are around, anything lower than 0.085 is probably a bad pixel. Anything lower than 0.09 might be a bad pixel. So for that reason, I set A equals 0.085. So what this says, the test is this a bad pixel? Is this pixel darker than it ought to be? If it is, do something, which I'm going to tell you about in a minute. If it isn't, leave it alone. Okay, so what's the do something? The do something says, find the difference between this pixel and the average pixel. And whatever that difference is, add some of it to the original value to make it a little bit brighter. How much is some of it? That's given by B. In this case, 35%. So go through it one more time. Check the value of the pixel. If it's a darker pixel than it ought to be, darker than that value, then find the difference between that dark pixel and the average pixel and add 35% of that difference to the pixel. Otherwise, leave the pixel alone. So watch what happens when I apply this. Pay attention to this. I'm going to just move it over a little bit. I'm going to undo that now. Pay attention to this little pixel here. Redo. If you want to make it more aggressive, you can go either of two ways. If you increase A, more pixels are going to get corrected. If you increase B, the selected pixels are going to get corrected more. It's really up to you. So again, let's look at this area down here. I'm going to draw a little green box around it. You see this right there. With this B set at 35%, 0.35, I get a little bit of correction. But what happens if I set it instead to 0.5? That's a little more. Oh, it gave me a syntax error. Did you see that? Invalid immediate symbol component value. Should have used the expression editor. There we go. I'd like to say that was a deliberate teachable moment, but it wasn't. There, did you see that brightening here? So that is a nice natural increase in brightness, not too harsh. As I say, if I wanted to also increase the number of pixels that get corrected, I could increase this a little bit to say 0.09. Now a lot more pixels get corrected. Now again, we're stretched. So now let's look at it unstretched. This is after and before. After and before. It's just a nice subtle smoothing. You don't want to take all the noise out or it won't look natural. And again, you don't need a mask for this. It'll only work on the darkest pixels anyway.
Ron, and
yes.
for a minute here. There's two different feeds here, and I can actually almost read what you've got there. But other folks reading on the web, they don't have quite the yeah. There we go. We want to see what those expressions actually say.
Yeah. So let me turn that up yet one more. How's that?
Yeah, that's better. Now we don't need to see every single one, but we need to see enough to know what you're talking about.
Yeah. So again, is the value of the pixel less than A? If it is, do this. If it isn't, just leave it alone. So it's only operating on dark pixels, with dark defined by us here. And what it's doing is find out what the difference is between the average pixel and this pixel, and add a fraction of it to brighten the original pixel value. And do that one channel at a time. Okay, I'm going to shrink this back down. Any questions about that?
So the if statement is like a mask, right?
Yes.
So you don't need a mask.
You don't need, its statement is like a what?
If statement is acting like a mask. It's sorting through if it's lower than that or not. So that is a mask.
Yeah, it's asking like it's acting like a range mask, but of course you can have masks based on all kinds of other things. But yeah, it's acting like a range mask.
Where is it getting its median from? The median of what?
It's the median of all the pixels in the image.
In the image?
Yes.
Wow, that's
well, most pixels in the image are very dark. And if you don't believe me, let's look at this image here.
No, I got it, because you're only dealing with the ones that are less than less than A, which is that 9/10 figure.
Yeah, but not only that, but even in a bright image like this, most images are dark. Most of the images are down here. Sorry, most of the pixels are down here, which is, down around 10%.
Okay.
That's the most common pixel value. And we're taking the median, not the mean.
Mhm.
So more than half of the pixels are dark.
Okay.
So this is a really robust, I found this works really well, and it can cover up a multitude of sins. Okay, if everybody's good with that, let's look at another thing that happens sometimes.
There was another question earlier.
Yes?
Adam asked if you linear fit the HA data to the red channel, or perhaps the red channel.
No, I don't.
That was
What I would do here is I would adjust the where's my HA? Here it is. Actually, I don't even need that. I need this. What I would do is I would just adjust this value here, the 1.2. So if I applied it this way, and I thought, well, that's not enough.
Could you use the magnifier, Ron?
Yes, I can. Sorry about that. Thank you for reminding me. Right. So it's this value here that I would adjust. So if I found that I wanted more, I could put that up to 5. But now maybe I would need to rescale. But that's not how this is meant to work. 1.2. I found, values between around 1. 1 gives you less nebulosity in the combine, but still quite a pleasing image. 1.5 is a little, oh, sorry, I shouldn't have rescaled. Let me just undo this. Hope nobody's getting seasick. So this is with 1. That's quite nice. And now we can try 1.5. I usually use around 1.2. There's 1.5. But you can still see the star colors are protected because the red is brighter than the H alpha on the stars. H alpha has small stars. So this works really well. The other thing is if you're going to increase the H alpha in the red like that, you have to increase it corresponding in the blue. Maybe just like that. That avoids that sort of orange hue that you get. And again, I can prove that by changing this to 0. So now nothing is going to happen to the blue channel. You see how we've got this kind of, it's better than the salmon pink, but to my taste, it's too orange. All right, I'm going to shrink down. Any questions?
Yes, Martin's asking, what protection is there for real dark globules if you were using that technique you just showed us?
There's no protection, but again, if the H alpha isn't quite a bit brighter than the red, it gets left alone.
Okay.
This test here only places H alpha where the H alpha was brighter than the red.
Okay. Do the pixel math expressions have an advantage over processes such as TGV denoise or multi-scale linear transform? John wants to know.
They do different things. So pixel math is all about altering. It's tough. Like, you still would use TGV denoise. You just might blend that result using pixel math with something else. It's all about, pixel math is all about blending.
Okay.
So maybe you make one version of the image that really maximizes how the big nebula looks, and another version that really maxes how the little one looks. And then you use masks with pixel math to combine them in some way.
Okay.
So pixel math is a blending tool.
Thank you. That's it for now, John, or Ron.
Okay. So let's see what I was doing here. Okay, we can close out of that now. We've seen that. So I don't know if any of you ever have a problem with sometimes bright stars getting a halo around them, a bright halo like this red star has here, right there. So that tends to happen for me and for most people I know with redder stars, but this works for any color. So the first thing we need to do is we need to make a star mask. Oopsie. We need to make a star mask, but I'm going to use some special settings that are going to allow me to make a contour mask. So in this case, I only want the rings around the stars, and these are the settings that I use. I know this is going to be posted to YouTube so you can get a screenshot later. So with that said, I'm going to shrink down and apply that to my image. And there's my contour mask, and I'm sure you can see we've got all the rings around the stars. So I could use that by itself if I wanted to, say, decrease the saturation. I could decrease the saturation of just the outer edges of the stars. But suppose that I want to focus just on the red stars. This has all the stars, this star mask. So I'm going to use a script here called the color mask script to select red and it's very quickly made this color mask that just has red pixels selected. I'm now going to blur that a little bit just because it's got a lot of sharp edges. Oops, way too much. Even that's too much. There we go. This is the one I'm really interested in. And you might be wondering, where's the pixel math come in? Well, the pixel math comes in here. If we open up pixel math, we can multiply these two images by each other. So think about what happens. Wherever there's a black pixel in either image, the value is 0. The result is a black pixel. Wherever there's a white pixel in both images, there's a white pixel in the final result. And whenever there's a gray pixel in both images, there's a gray result. So this should select just the parts of these halos that correspond to red stars. That's what I want to do. And I'm going to do the halo fixed demo mask. That's the one on the left. And I'm going to multiply it by star mask 1 that I just made. Let's check it. All right. And I don't need to rescale, because the highest result I could get by multiplying 2 black and white images together is 1. There's no way to get a number bigger than 1 by multiplying 2 numbers less than or equal to 1. So let's make a new image. Invalid symbol identifier. Oh, I put it totally in the wrong place. Silly me. Again. There we go. So now we have a mask that's black everywhere except for where there are red halos around stars. And I can now stretch this mask to do surgery very selectively. There we go. Now I can use this mask. If I place it on here, it's really just going to select for where there's red pixels around stars, bright stars. So you can be very, very targeted. It's getting some of these flares. Some of these stars seem to have little red flares. And that's what's getting picked up in those masks. Okay. I think that was all that I wanted to show you. And I think we're at about 45 minutes.
Well, that's very good.
Yeah, excellent.
Yeah, that was, I love the way you just go through it. I don't see any new questions coming in. I think we picked up everything along the way. We had one side conversation about gain and ISO, but I think that's been taken care of. While I got you here, Ron, you just finished a workshop last weekend, right? Down in
Yes, we did.
Texas. Tell me what happens at those things.
Well, it's a 3-day event, a lot of fun. It's for beginners who are really prepared to roll up their sleeves and work, and that includes doing work a little bit ahead of time. You have access to some free primers that Warren is prepared to get used to the user interface. But I can actually show you the agenda for these things. So the next one, by the way, is going to be in Kitchener, Ontario, if anybody is local. So if you go to ipforap.com, where the heck is it? Here it is. There's the workshop agenda that you can look at. So we start out with the desktop.
Get that magnifier going a little bit.
Yeah, sure. Right. So we start with just some introductions and then spend the first half of the first morning just finding our way around the desktop. Then we show you how to evaluate your data and reduce it with batch pre-processing and introduce projects. The second part of the day after lunch, we get into basic pre-processing. And all of that up until the break, we don't use any color data, because color is a distraction when you're learning concepts. But before the end of the day, we do bring in the chrominance and what you need to do to make a color image or how to work with one-shot color. That's all on day one. Day two, we get a little more sophisticated in the pre-processing. This is more of a demonstration, but then we continue on with the project that we started on day one, get into all the non-linear stuff that you need. And there's a session on making and using masks, which we then use for additional non-linear processing. Day one in the afternoon, or sorry, day two in the afternoon, we have our first individual coaching session. So people can work on their own data or on our data, and we help them with whatever they need. So if you're a little more advanced, this is where you can pull more information out of us. And then we finish up the day with a little bit of special sauce, getting the color saturation and bringing out details in the core. Day three, we look at getting the most out of PixInsight, so customizing the settings. And we have 2 process your own sessions punctuated by a couple of really useful scripts. We have a demonstration similar to what I've shown you here today. And that's the workshop. So it's 3 very intense but fun days.
How many people are?
Thank you for asking, Alex. Pardon me?
How many people are at these things?
We've had up to 24, but typical is about 18.
Okay, so we've got time to spend with you.
Oh yeah,
Yeah,
definitely.
okay. Good.
Yeah,
John.
and both Warren and I also do private tutoring. Some people work better in that environment, but it is good to kind of get away from everything else and do nothing but PixInsight for a few days.
Hmm.
It really get you over the hump.
Okay. Okay. And John just wanted to point out that Warren's workflow videos on IP for AP are pretty good, and he'd like to see more of them. And I know you work with Warren all the time. You can pass that on to him.
Oh yeah, definitely.
Are you doing anything at NEAC or NEAF, or are you just going to be there?
Yes, I will. I will be at both. And at NEAC, I am doing an introduction to astrophotography. It'll be a series of 4 one-hour lectures. The first one is going to be on different types of astrophotography. The second one on equipment, third one on software, and fourth one on getting around stars.
Okay, cool. Shall see you then.
And you also have a workshop too, don't you, Ron?
I'm not doing a workshop there.
Oh,
This
you're
year
not
I
doing
did.
a workshop. I'm sorry.
No, I think Adam Block is doing one.
Well, many people are doing it. I didn't know if you were doing one too.
No, Bob didn't ask me to do one this year.
Okay.
Okay.
Which is fine. I get to hang out at the bar.
Hey, stop that. Okay. I think that's going to wrap us up for, we're taking, we're taking a
That's
week
my
off.
dog. Sorry.
Yeah, we're taking a week off next week so we can go to NEAF and NEAC, and then we'll be back the week after that with something. I don't know exactly what yet, but we will come up with something by then. So we shall see you all. Thanks for being here, and that's it. Thank you very much, Ron. That was a great show. Okay, thank you.
Okay, all the best, guys.
Okay, bye. We're going to stop the
Take care.
podcast
Bye-bye.
here. Stop.